All right, so let's talk about the third and the last pillar of the observability, being the distributed tracing. And here we'll be talking about what the tracing is, how we can use the OpenTracing schema, and how we can use tools like Jaeger to provide this distributed tracing to our microservices.
Yeah, exactly. So if we think about the fundamentals of the distributed tracing, we should talk about the span. Now, the span in terms of distributed tracing would be nothing more but some sort of unit of work. So if we consider span in terms of web API, the most general span would be web request, right? So the span would be simply some sort of web request that comes to our API. Now, the span itself has some start and stop, so some boundaries put it into the time. And now the crucial part is that the span can be with the relation. Actually, there are two ways of the relation, the connection to the other span. So first is the child. So one span can be the child of the another. So if you would come back to this web request, so we could have this red span as a processing our whole HTTP request, and let's say that the child would be another span that would represent seeking into the database for some data, okay? So that could be the part of processing this web request. That's why this is in the relation of the child.
Yeah, we can have many child, and might have an old child. So we could have like a parents file and a children and a single child and so on.
Yeah, this might go even deeper, right? And the other relation is that the one span can follows from the another. So we could think about this like, so within our web request, we had seek in a database, but then later we called another web service.
Yeah, like in the reserve resource handler, when we are asking customer service to get a state, and it's like, it's no longer within the scope of this web API, but again, somehow we got this correlation ID as well, and there is like another span which has this parent that originated in this, for example, availability service.
Yeah, so basically this is the idea. The whole system, our distributed system, will have to produce this spans somehow, and based on this we'll actually do this visualization of how this data is actually processed and where goes the actual HTTP request. Now, if we take a look about the internals of the particular span, here's also quite a lot of information. So basically the most important part is the context. So context contains basically the trace ID. So trace ID is something that we're already familiar with, but we used a slightly different term. So this is some sort of the correlation ID. So each span within the trace will have the same trace ID. Basically, then we have the span ID, which is just the identifier of the particular span, and we have a baggage, which is some sort of bag for additional metadata.
Yeah, any arbitrary data you can put in there.
Yeah, and this baggage will be propagated to the newly created spans. Besides that, we have a process name. So once we actually visualize our spans, we could see, okay, so this was the span responsible for seeking in the database. Then we have the tags, of course, for the querying purposes. And what's also interesting is that we can log to the particular span. So we'll have additional information.
But we probably shouldn't put there like big stack traces, because if we start sending a lot of spans to these tools like Jaeger, then it might affect our network bandwidth. And this is probably not the best place to drill down into the logs and stack traces.
Yeah, exactly.
But some informational stuff.
But for some scenarios, this might be helpful. This is rather an additional information rather than a substitute for, let's say, the secu and the server. Okay. So let's talk about how we can actually efficiently trace an app. So once again, we'll need some way to actually define and create these spans. We'll also need to query them and visualize.
So it's like pretty much the same as with metrics. We need a way to define the metrics and the spans. We need a way to query the metrics and the spans, and eventually we need a way to visualize these queries, the spans.
Yeah, exactly. Yeah. So for this defining thing, we'll actually use the OpenTracing. So OpenTracing, we'll get to this in just a second, but basically this one will allows us to create the whole I would say the instrumentation for our application, and then we'll use the other open source project.
Jaeger.
This time, Jaeger, created by the Uber. So this will allows us actually to query and visualize this. So maybe before we actually move to the OpenTracing, we can see how this the whole setup will actually look like. So basically, we'll have our application, and our application, so in our case, that would be a particular microservice, will have this OpenTracing instrumentation on top of this. So this will work kind of similarly to what we've seen with the metrics. We'll simply enable this, and out of the box, we'll immediately start reporting some spans. So besides that, we'll have a client. In this case, that will be the Jaeger client. Client will simply report to some sort called collector. Collector will simply then put this into data store. And worth mentioning that the default one will be the Cassandra, but you have also plenty different data stores that you can actually choose from. And then you will have the UI on top of this, right? So you have some query language built in Go, and the UI using which you can actually see the spans. Of course, this looks way more complicated than we've seen with the metrics. But fortunately, the Jaeger provides very cool Docker image that allows you to bootstrap whole this infrastructure using just single line of code. You just need to expose few more ports, but basically this is called something like Jaeger.
Yeah, we have this Jaeger tracing all-in-one. It exposes quite a few ports, but we don't have to install anything else or set up anything else.
Yeah, but if you want to, let's say, switch, because there are also some additional piece of the infrastructure, you can also evolve the Kafka in here for streaming. So if you want to replace some part of this infrastructure, you can create this from scratch using different images. So yeah, this is the idea behind this. I think that looks complicated, but if we go to the code, it will be much simpler.
Yeah, and you mentioned the OpenTracing. So the OpenTracing is more like a schema, just like ECMAScript is a schema for like JavaScript language and its interpretation.
Yeah.
So it's like language agnostic schema for making this instrumentation APIs.
It's not a standard, it's more like the specification.
Yeah, like specification. So again, we have like multiple most popular languages that do support it. Currently, there is a shift. So even if you go to this OpenTracing.io official website, you will see that they are merging all this stuff into the so-called OpenTelemetry. So for the future projects, the OpenTelemetry will most likely be a way to go. But at least for now, when it comes to .NET packages, and you would start searching for official NuGet packages that support .NET, this OpenTelemetry with .NET, you would see like that there's a lot of packages being still in some preview or alpha, maybe even beta mode for now. So probably not the best choice for the production usage. For like local development and some sandbox and sort of testing, that might make sense. But for the production usage, we would rather recommend to stick with the OpenTracing for now until we get the first production-ready packages for OpenTelemetry. But eventually, we'll get there, and the overall idea will be pretty much the same when it comes to tracing, metrics, monitoring, and this sort of things.
Yeah. Okay, so we have this two things. So we'll have this OpenTracing, eventually OpenTelemetry, and the Jaeger. So we can jump into code and see how the Paco availability service can actually make the use of this.
Yeah, so Jaeger, Tracing.io, again, another project, like a very major project under Cloud Native Computing Foundations on CNCF.io. You can find it here. Like you said, made by the Uber, maintained by the Uber. So they have, I think, thousands of microservices already. So they know what they're doing. And
yeah, they made the previous one, which was very popular, was called the Zipkin. Then made the transition. They made their own product, which they maintain. So yeah.
Yeah, and for .NET, we'll be using this official Jaeger tracing library for the C#, and also for the OpenTracing. If you, for example, go to the NuGet org and you will just type OpenTracing, you will see that there is, again, quite a few official OpenTracing libraries with some additional capabilities, for example, for gRPC, Mongo. So just like with the metrics, it seems that you might get a lot of these things totally for free without even coding anything. You just install the library and there it is.
Yeah, exactly. So if we get back to our availability microservice, of course, this will be once again some cross-cutting constraint that we would like to keep in the infrastructure. So basically, we will have for now we'll focus on the one additional package of the Convey package. So very small wrapper on top of the Jaeger client. So we have this Jaeger tracing Jaeger. So we can add this as a following. Add Jaeger.
So just like we did before, add Jaeger like we did for metrics, and then use Jaeger, because again it will mostly, but not only, as we'll see later on, work on top of the HTTP requests, and it can be plugged in easily as a middleware.
Yeah.
So maybe we can also go to this extension, just see how we can register, because there are also some interesting parts when it comes to adding the Jaeger to the code. So when we open this library, you can see that we are using this official Jaeger package, and we also use the official OpenTracing library for .NET Core. So again, one more time, a wrapper on top of this, which in that case will be like shared by all of the microservices. So we would expect to have the same behavior when it comes to logging, metrics, and finally the distributed tracing for our whole ecosystem of the microservices.
Yeah, exactly. So, but basically, once we actually call the Jaeger, the main purpose of this extension is to create so-called tracer. So basically, the tracer will consist of two important things. The first one would be the sampler, and the other one would be reporter.
Yeah. So even if we decide to have this feature switch disabled and we make Jaeger disabled, then we'll use this empty tracer. So we have this default tracer create, which is of this no-ob reporter type. So it will just be there, so we can inject it within some services or background services. So we won't get an error when it comes to DI, but it will do nothing. If we register it, we'll just need to register it here. And also this invocation to add OpenTracing, again, comes from the official library, from this OpenTracing library that you can find in NuGet. So that's how you actually get all of these features for free. But you only need to register, for example, like we do here, the Jaeger on your own, and you can choose from these different tracers, samplers, reporters, and so on.
Basically, when it comes to the tracing, we need to think about, actually consider two things. First is how we can actually report this, because this will be work slightly different rather than we had with the metrics. So in this particular model, we won't have anymore the pull model, we'll have the push model. So we'll have this client that will fit into our instrumentation, and we'll simply grab this whole spans produced by our application, and this will report this to the Jaeger, right? To this so-called collector.
Yeah, so we have this reporter, and also important thing to notice is that we are using this UDP sender, right? So we don't really care even if we were to lose some of the packages. We don't want to establish like a full TCP IP session at the level. We just want to deliver it as quickly, as efficient as possible, because we might actually end up in sending lots of packages through the wire. So we want to make it as efficient as possible.
Exactly. So we have this free of choice. Of course, in here we decided to use the UDP. So this is the way how we actually can report the spans. But we also need to consider how we can actually reduce the number of spans being reported to the Jaeger, because if we'll have like the very high number of the RPSs, this could pretty easily kill our Jaeger, because we'll report thousands of the spans, and also will decrease the performance of our application.
So like you said, we have another IO operation. So whenever there's IO, there is a cost. And if we start reporting each one request, we'll again start sending lots of data to Jaeger, and it will also decrease our application performance because our web API has to send it. So it's like IO operation that has a cost.
So basically the get sampler will based on the options provided in the app settings, will create the sampler. So you can choose whether this is a constant sampler, so every 1,000 message will be sent, let's say, or maybe being based on some other heuristic or the probabilistic and so forth.
And we can find the sampler types, so you can choose choose the best sampler for you on this Jaeger client C# on GitHub.
Like 6 of them.
If you scroll down here to this sampling, you will find this both documentation for reporting and the sampling. So you can just open this two links, and you will see those documentation about
the Convey support is just free, but there's much more samplers than the one that we covered. So this is the idea. So you have this having this reporter and the sampler, you are ready to create the tracer. So the tracer, comparing to what we've seen in the metrics, will be something like iMetrics root. So this will allows you eventually to create your own spans within your application. And that's pretty much it. Basically, we do the global tracer register, the tracer, and we are ready to go. We have just one tracer, so we're registering as a singleton. That's it.
So within our application, when it comes to defining our custom spans, if we need to do it, because we can just inject this iTracer, which is a singleton in that case, and just like the metrics, like you said, we can just do the spans and add some logging, add some more tags into them, and just put them on top of everything you want.
Yeah, I would also add that maybe not just because we can, but also because sometimes maybe there's a need. Because having this spans produced by our application, this will actually allows us to do pretty good investigation when it comes even to the performance. So let's say that we have this weird behavior of our application in which for some bizarre reason we have the request that takes 3 seconds. Now, from the metrics perspective, it would be pretty hard to judge why this actually took 3 seconds, okay? It's because we can have the metrics for the overall request, but maybe we would like to see what part of this request took the most. So if we'll having a lot of spans involved in this whole process, it would be much easier to see, okay, so this span, because just remember that the span has the start and the stop. So we can see, okay, so the connection established to the database took 2.5 seconds. So this was the majority of this request. So this will also help us analyze our system. On
a different level.
Yeah, actually. Different dimension. Yeah.
Different dimension. So I think the last missing piece is this app settings. Right?
Yeah, exactly.
So once again, we'll have our app settings. We can find this Jaeger section here. So we have our service name, which we'll be able to pick from when it comes to Jaeger UI and this drop-down list. We have our connection string, so the connection details. We want to send these Jaeger packages because it will run on local host in that case under this port. We chose the sampler, and also just like with the metrics or logging, we may want to exclude some paths. So maybe we don't want to see that Jaeger will be, for example, we'll track the packages coming from these endpoints. So this is a place where you can easily define it on top of your framework. So actually, when you put this exclude paths here, when you include them, it's simply on this ASP.NET Core diagnostic option. So it's not related to Jaeger itself. It's more on the ASP.NET Core framework level. Yeah. This option is being set. All right. So let's get back to the code and let's just do this local switch for the AppSync local JSON for Jaeger. And let's see, maybe we start it up and we will start seeing anything on the Jaeger UI.
Yeah.
So we can access the Jaeger UI at 1.6.686, this long port, 5 digits. And for now, there is nothing. There's 0 services, right?
Yeah, exactly.
So let's restart it up.
Yeah, we should see in a minute that...
Yeah, we could send some requests to our service again. So let's go back to our REST file.
And create new resource.
Yeah, let's create a new resource with this ID. Let's do some get. Maybe let's try to create a resource again with that will result in an error. All right, and now we can go back to Jaeger.
Yeah.
And we should see the service here. So we have this availability service available. And let's do find traces.
Yeah, so we have some information here.
Yeah, we have, for example, this post message, right?
Yeah, so at this point, we do have just one span, but once again, this one was produced by the OpenTracing just out of the box.
Yeah.
Just keep one more thing, which is also worth mentioning. Remember that we did get rid completely of the MVC controllers, right? Mm-hmm. So we have very simplified pipeline when it comes to the HTTP request processing. If you would rather use the MVC controllers, I believe that by default you will get 3 spans. So one would be the whole HTTP request processing, and the one dedicated for the MVC controller, and the third one would be for the particular action in this controller. So we have kind of simplified span here, but even though we have some meaningful informations.
Yeah, so we can see that there was the URL, we made a post method to this one, we got the 201 status code. So we already see that there is some request and HTTP going on, and even though we don't see any services besides this one, there's something happening.
Yeah, maybe we could also try to reserve this resource.
All right. So to do it, we'll need to start the customer service.
Yeah.
So maybe also let's start the customer service with Jaeger integration enabled. So we'll see both services there. So simply go to the customers app settings JSON, just like we did with the Jaeger here, and just made the switch from false to true. And let's start our service in the app. So in the console, so start. All right, so we have our customer service up running. I'll also probably need to create a new customer. So I also started an identity service. So maybe let's start a new one service that will also report to Jaeger. So we have like 3 services.
I think that the only purpose for this is just to see this interaction between. Because,
okay. Even if it fails, right?
Yeah.
All right, sure. Let's do it this way. So let's try to reserve the resource, which is here.
Yeah, we had a null check, so should be fine.
Yeah, let's see if it works.
Yeah, so now let's get back to Jaeger, filter this once again.
Yeah, and we have this post again, which actually is all about 2 different services, the availability one and the customer. So let's click onto this one.
Yeah, and that's the beauty of distributed tracing. So we had one HTTP request to our microservice, but underneath there was a communication. So just keep in mind that we had this additional requirement in which we need to check the customer state first. So there was an interaction between the availability service and the customer service, and we can see this at this diagram. You also have some metadata at the very top of the UI, so we can see how many spans we had, what is the total depth.
The timing is also nice, the whole duration, and here we can just see like the whole span, how long did it take, and also the child spans, or these the spans with this follows from relation.
Yeah.
So we have the post, then under this URL, then we have the get, and this get eventually gets into this, it's being sent to the customer service, which actually returned in an error and a 404 status code.
Yeah.
And we can also change the view to, for example, this trace graph. So we'll see it this way. The first post, get, and the get, and we can also go to this system architecture. And if you go to this graph here, for now it's just simple like a dependency between one service and another. So in that case, we send just a single request from availability service to the customers.
Yeah, but we already see that there is some coupling between the availability and the customer service. So given the fact that we'll have like up and running a lot of more microservices, we would make a lot of more HTTP requests, we would already see that, okay, so I have the temporal coupling, because let's just remember that this happens on the HTTP level. So we are talking now only about the temporal coupling. So we can see that, okay, so I do not recall having this requirement. Maybe I should consider this connection. So this is something that you could not achieve with the metrics, or maybe that would be much more hard to achieve.
Yeah, and we have a very nice graph here rendered, so we can just take a look and see if there isn't maybe too many dependencies. Maybe we are not really doing microservices, but this distributed monolith, because everyone's talking to another, and each service knows everything about the other services. So,
yeah. So let's give it a try, and let's try to actually implement or maybe create our own custom span. So once again, we could create a simple decorator for this purpose.
Sure. So let's make a new decorator for this, and let's call it Jaeger command handler decorator. Let's make it an internal field class. And of course, it will implement our iCommand handler of T, where T is a class and the iCommand. All right. So now let's implement these missing members. Let's make it an async. And of course, we'll need to inject the things we are decorating, the command handler, along with this iTracer.
Yeah,
right?
exactly.
So let's inject our iCommand handler of T handler and the iTracer tracer here. All right, so now we'll need a way to actually define our custom span, like new child span.
Yeah, we need the scope actually. So we can think about the scope actually this will be the disposable object, which will define the boundaries of our span. So basically we can think about this that the scope will be defined within the using block. So it starts once we actually reach the open bracket, and once we actually reach the end of the using scope, the span will make it automatically finished.
All right, so let's start with our message name, or the command name in that case, which can be just command get type name, and let's call this underscore extension to have it snake cased. Next, we will need to create our scope, right? So we can do something like using scope equals, and then we can try to build this scope. So let's say we want to have the set method. Yeah, let's create this one. And this will return this iScope, just to not get confused with some IOC scoping. The idea is similar, but this is just a different type coming from this OpenTracing NuGet package.
Yeah, exactly.
So let's define our scope. Like you said, so we'll have the scope that will be equal to the tracer. And from the tracer, we can invoke this build span. So we need some sort of process operation name in that case.
Yeah, this will be simply name. We can take the command name.
Okay, so let's call it like handling in our command name, for example. And maybe let's put some custom tagging as well. So later on, we could, for example, find all the spans that match this message type, let's say add resource.
Yeah, exactly.
So we can easily query such spans, say message type, and it will be our command name once again. And now we need to verify, because it might turn out that we already have an active span, right?
Yeah.
So
basically, yeah, if the tracer.active span, so we have this property available. If this property will be equal to null, this means basically that we want to create an initial span for our HTTP request. Otherwise, we would like to connect this somehow to the existing active span using one of these two available relations.
Yeah, so it seems that this should be the reference of type child of.
Yeah,
because it already exists in the same web process, same web API. So the follows from wouldn't make a lot of sense here. So we just call the child of reference here, and we can just pass our active span context. Otherwise, we'll just return the new span anyway, the new scope. So let's call scope, and then we can invoke this start active. So we have a new scope, and there is this parameter finish span on this post. So we'll just set it to true, right?
Yeah, because this will actually allows us to forget about stopping this manually. So once we reach the end of the using block, we'll simply stop the span. And one more thing, which is also worth mentioning, is that when you actually invoke the add reference method, you pass, along with the type, you pass the context. So as we remember, the context provides the trace ID and the baggage, which could be which needs to be actually propagated to the newly created span. So this is why we also need to pass this.
All right. So now let's grab our span from the scope. So we have this using block here. We can just take our span using this property. And now maybe let's put this into this try catch block. And we will want to rethrow this exception here, because as you might remember, we have this exception to response mapper, which deals with mapping the exceptions, for example, during this HTTP request and some failures. So we don't want to swallow this exception here or at the different level. And let's just try to invoke the handler, right?
Yeah.
And maybe put some login.
Yeah, you could also log to the span directly. So the span object itself allows you to do this.
Yeah, so we have this log, and let's call it like handling a message. And then our maybe type name. So in that case, we'll have our command name once again. And then let's just do copy and paste of this guy. And let's say handle the message. And also within the catch, we could do something like log and maybe log our error here. So we can just log exception message. Probably we don't want to log the whole stack trace there.
Yeah.
We can drill down the stack trace in some centralized logging tool. But we can also set some tag for this error. And we have this tagging option here via the set tag method. And we can either provide some custom tag, but we can also pick one of the existing tags. So there should be this error tag. Yes, so let's make an error.
Yeah, that will be a nice example that will also be noticeable on the Jaeger UI. So this is the way that we can actually decorate our command handlers. The only thing left that we need to do is actually registering this decorator in our IOC container.
So the same stuff like we did for the outbox and inbox pattern. Exactly. We can just change this to Jaeger command handler decorator here, and that should do the trick. Yeah. Okay, so we can try starting our service once again.
Yeah, add some breakpoint.
Let's put some breakpoint also here. We should have this also on the Jaeger decorator level. And let me just check. Here's our customer service. Everything is down besides this one service. So let's start our availability service with this new decorator for Jaeger, and let's see how it goes.
Yeah, so we should go to the Visual Studio Code and try to reach our availability microservice once it's actually up and running.
So let's go to VS Code REST client once again, and let's try to, let's say, create a new resource with ID of 3. So we are just hitting our decorator for Jaeger. We're sending this span, logging something there. We are actually invoking our internal handler that we just decorated. We created a new resource. We handled the message. There was no error. So maybe let's try to produce another span, but maybe that scenario with this exception.
Yeah, exactly.
So let's do just the same. Post F5. We should get this exception here. Okay. We should catch this exception, log this exception message along with the span, set the tag to be error, and just return this error status code from our API.
Yeah. So let's look at the Jaeger UI. Yeah. So we already can see that now the availability service, instead of one span, produced 2, right?
Yes. So let's take a look at this successfully processed command.
Yeah.
And here is like our OpenTracing span, and this is our custom span here, right? As you can see, we have some logging, handling the message, add resource, and some tags as well. And our custom tag is visible here.
Yeah. So we could, at this point, actually be even more precise and produce more spans, let's say, for the decorator for the MongoDB. So we could see what was the actual processing time for this particular driver, right?
Yeah, and for MongoDB or gRPC or other technologies, we'll find already existing ones, extensions on a NuGet.
Yeah, but this is pretty cool.
Yeah, we can see this. There's some error, right? So let's click here, and let me just zoom out a little bit, and we can see this exclamation mark with this within this red circle there. And here are some logs. Here is this error true tag, and there is handling message. And then we also log this exception resource with ID already exists. So that's nice. I mean, at that point, when I see this span with this error tag, right, I can go to my logging system and then start drilling down, looking for the stack trace if there is something that isn't as obvious as this error message.
Yeah, but we just are missing actually one more thing, because the Jaeger itself works on top of the HTTP, right? So it uses the headers, the capability of having the headers, and this is how this works behind the scenes. However, in our system, we do also have the asynchronous mechanism, right? We can asynchronously exchange these messages all across microservices using the RabbitMQ. And from the developer's perspective, having this event-driven architecture will be pretty nice to have this information among with the other. Is there any way to actually combine Jaeger somehow with our RabbitMQ messaging?
Sure, whether it's RabbitMQ or anything else working on top of AMQP, whether it's some other message broker or service bus technology, well, it doesn't really matter as long as we can, for example, attach some additional metadata, and with AMQP and RabbitMQ, we can do it simply with the headers. just like we can pass some custom headers with HTTP request. So we already know how easily we can create our custom spans, right? Like we just did for this Jaeger command handler decorator. And let's just go back to our extensions.
Yeah, because from the Jaeger's perspective, the crucial part is to have this information about the trace ID and eventually the baggage, because this will allow the Jaeger to correlate newly created span and correlate this with the already existing trace. If we'll find a way to propagate this somehow using the metadata of any protocol, we can integrate this with the Jaeger with no issue.
Yeah, so for RabbitMQ, let's just call this Lambda method. So we'll have these plugins there, optional plugins that we can define as we shown you in this message broker section. And we have this add Jaeger RabbitMQ plugin extension. So let's just see what it does. It will be a very simple custom span implementation down below. So if we look for this one, we'll just register our Jaeger plugin. And this is nothing more than passing this actual context as part of our AMQP headers. In this case, when we are working with the RabbitMQ message broker.
So the context itself has the overloaded toString method, which does sort of the serialization, I would say.
Yeah.
And we also have the Jaeger also provides the class that will allows us to deserialize this to the context on the C# level.
Yeah. So here we are asking for this. We'll just call this span context header on top of our RabbitMQ options, so we can define the custom header key here. Then, if this header exists, we'll just get the string out of this header, and finally we'll build our scope, just like you said, based on this serialized span context. And we check whether it's an active span or not. We just create a new scope, and we set this reference here to follows from, because this is actually an asynchronously processed message, event, or command, whatever it is.
Yeah.
So it's like outside of the scope of the service that actually, produce this message within some event or command handler. And we just start a new span here. So this is how we can actually connect these two words, the HTTP transportation layer, along with this AMQP protocol in this case, or with other message broker or service bus technology.
But we need to remember that once we actually would like to publish the message, so in this case we have this abstraction on top of the publisher, which would be message broker. We will need to at some point get this information about the active span from the iTracer, call the toString, and pass this to this method, right?
Right. You are correct. So yeah, but it seems like we are good to go in the scenario. So maybe to see the actual beauty of distributed tracing, let's just try to start the whole system. Let's start all the microservices through the Docker Compose tool, and we'll see once we start sending these requests, like a lot of data being sent through the wire, and a lot of different services talking to the other microservices, and then we'll see this whole graph of dependencies being rendered from the Jaeger UI,
that's this
web application. So let me just kill the currently running customer service, and let's just go back to our Docker Compose. So the infrastructure is up and running. All of the other services are down. We can just do Docker Compose -f services local YAML up. So let's start all of our microservices through these Docker containers, and in a few seconds we should be able to start sending requests. We already know the Prometheus, so we can go back just to verify that everything is there up and running to this localhost 9090 and just check our status targets here. All right, all of the services are up. So let's get back to our VS Code, and let's open the
sample scenario
REST for our API gateway. So you can find this one here, as usual, under API Gateway project. So let's try hitting some of the requests. Let's load this one. And yeah, let's do it. So sign up, sign in. Let's do a few more. Add parcel, add new order. Yeah, let's go through them.
A lot of traffic,
Yeah, let's produce a lot of traffic. We can actually complete this one. Should be quite straightforward, actually. post, another post, complete, get. All right, so we just started quite a few requests.
Yeah.
And let's go back to the Jaeger now. Let's refresh the whole page. We can see now that all the services along with the API gateway are registered in the Jaeger. So this is what we want to have in our microservices to have each microservice connected to this tool. And then let's look for find traces. So maybe on the API gateway level, being an entrance point to our distributed system. And let's look. All right, there's nice one. Like let's click here. And what do we see? So we have this, for example, pause request to this localhost 5000 deliveries. So through the API gateway, we would hit this delivery service with an HTTP pause method. And then we can see in action that there is some processing, delivery completed event.
So this is on the RabbitMQ level.
Yeah, this is actually our Jaeger RabbitMQ plugin. So there was, within the service, we produce a single event, but we can see that there are like 4 services, or actually 3 services, the orders, customers subscribing to this event, along with our operations service that we used in one of the previous lessons to send these push notifications in real time to end user through WebSocket, SignalR, gRPC to notify about what's going on.
I think that we have also one cool example of the temporal coupling. If we get back to the list of this spans, I think that we have like somewhere. This. I think this is
one?
this one. Yeah.
Let's try this one. Oh, there is quite a few.
So basically, this is this temporal coupling chain in which the API gateway calls the orders.
Yeah.
Orders for some reason needs in this case the vehicles. Vehicles ask the pricing, and we have a lot of actually information exchanging all across our system.
Yeah, we can also see that it all goes through the fabulous balancer here.
Yeah.
So at least the traffic is properly distributed. But like you said, we have the API gateway redirect to the order service, then orders redirect to the pricing, then pricing to customers. So quite like 3 different services had to communicate with each other. For example, to perform this request stating that we want to actually assign the vehicle order, whatever it is. And we can also check the dependency graph now, right?
Yeah, exactly.
So let's go to our graph here at the system architecture, and now it looks like much more informative than it was before when we had only 2 microservices there. So we can fix a little bit, and then we can look at such graph and start wondering whether this is something that we would expect from our distributed system or not. Whether there's maybe like too many dependencies between different microservices that shouldn't be aware of each other or not. So the distributed tracing gives us also this like a big picture of where do we send the request, or how many requests do we send to which service, from which service.
Yeah, exactly. So I think that's it for this topic. So we covered the observability. We discussed these 3 pillars. So we had this logs, we had this metrics, and now we had this last piece, which would be the distributed tracing. Just keep in mind that they are not. They should not be treated as some sort of a replacement for each other. This is just 3 different topics that working together, putting together in our system will do the job really well.
Yeah, so we just talked about the last one, the 3rd pillar of the observability, starting with logging, then through the metrics and monitoring, and now finishing this observability topics with the distributed tracing.
Yeah, so we'll move forward to more DevOps stuff.
Yeah.
Even more DevOps stuff.
Even more DevOps stuff, security and DevOps stuff, because there are still quite a few infrastructural pieces missing to make this system complete.
Exactly.